Good afternoon and welcome to NASA's Kennedy Space Center. We're here today in preparation for a launch tomorrow morning of SpaceX's 7th Commercial Resupply Services mission to the International Space Station. It's set to launch at 10:21 a.m. Eastern Time tomorrow, and our launch coverage will begin at 9 a.m. Eastern Time tomorrow. This mission is carrying more than 4,000 pounds of supplies and payloads, including critical materials to support more than 30 student experiments, and more than 35 ongoing investigations for expeditions 44 and 45. Among the payloads on this mission are the student experiments and the first of 2 international docking adapters that will enable commercial crew vehicles to dock to the International Space Station. We'll be discussing these things today in our briefing. The station's role as a U.S. national laboratory, managed and supported by the Center for the Advancement of Science and Space, or CASIS, makes possible numerous investigations, including more than the 30 student experiments. Student investigations from the Student Spaceflight Experiments Program and the National Design Challenge will be flown on Dragon and returned at the end of its mission. Using NanoRacks experiment modules, these studies will span a wide array of scientific disciplines. Some of the science objectives include testing a new hypothesis to simulate pollination in microgravity for food crops, investigating a new type of plastic to block radiation from the sun to protect future astronauts on a journey to Mars, and analyzing the performance of a new energy source called solar liquid power, which combines nanotechnology and electrochemistry in the form of a paint-like coating. CASIS has developed a science, technology, engineering, and mathematics education initiative entitled the National Design Challenge, intended to further CASIS's efforts in encouraging students to become more excited about science. 2 Houston schools and 3 Denver area schools will be sending 7 total investigations to the ISS National Lab. Here to talk with us today about their investigation are Heidi Smith and John Weiler from Bell Middle School in Golden, Colorado. So Heidi and John, will you tell us a little bit about your investigation?
Sure. So our investigation is to see if red wiggler worms can compost in a microgravity environment. So we chose red wiggler worms because they are actually a very hardy worm, and they are used for gardening, and they compost very, very well. So we wanted to see if they can compost so we can have gardens and crops on the ISS for astronauts to eat.
Great. And what was your role?
I was in the biology team. I was one of the leaders.
Okay.
I'm in the engineering team, and we were responsible for creating this box and programming it. Using the NESI microcontroller and 3 sensors, we would be recording what happens to the worms when they're up in space. My job was to oversee all of this, and we used a camera, a moisture sensor, and a temperature sensor. These 3 sensors would record how the worms were responding to the microgravity environment. The camera would take pictures, a picture is worth 1,000 words, and the moisture sensor would record the moisture in the box as the experiment progressed. The temperature sensor would be responsible for seeing how the worms emerged from cold stone reanimated, as Heidi will talk about later.
Great. Thank you. So how long have you been working on this experiment?
We've actually been working on this all year. I got an email at the beginning of August saying that we are actually going to do this experiment, and so they were just, my teachers, Ms. Atzmiller and Mr. Swift, they emailed me, and they said, we are going to do this experiment to see if red wiggler worms can compost in microgravity. So we started this entire school year, and it's awesome that it's so close to being launched.
Yes, for me, this project started about a year ago in July. We went to a local museum and met with some CASIS officials and got all the parts, the nano lab, which our experiment and the box will be going in, and that was the time we started our experiment. we had all school year to work on this in our separate teams, and this at the end of school we had a final design prepped. This box, the worms would go in it, and the compost, and this was all being sent down here to NASA where they would load it onto the shuttle. So here we are.
So how many worms go into the investigation, and how do you expect it to proceed?
So there will be 11 worms that will be going into the 3D printed box. And so I think that this experiment will go very well. Personally, I hope it will, just because we have spent a year on it, and these worms, through some of the experiments, were very stubborn. They did not like it, but now they push through, so I think it will go great.
Great.
Yeah, with all the effort that we have put into this project, and with all the ideas we've come up with, and all the ideas we've shot down, and all the changes we've made, I really hope this will work. And I personally have high expectations for it, because we've planned for a lot, and I think it'll work.
Hopefully.
And so when you say we, it was more than just the two of you, presumably.
It was the 8th grade iSTEM class at Bell, 60 of us, all split up into different groups, all working on a separate problem. And together we designed and created and completed our experiment.
So who are we looking at now?
This is the software team. This is my group. We got Jake,
Okay.
Linus, me, and Hans. We were responsible for programming the NESI microcontroller, which would take the readings from the sensors every 6 hours, 3 times, at 1 minute intervals, and record exactly what's happening on board. At the end of the mission, we will retrieve the SD card from the NESI microcontroller, and we will see what has happened on our experiment.
And I think this looks like must be the whole team.
Yes, that is all of the teams in this experiment, all of them. It's
all 60 of us. We've labored for countless hours to get this up and running, but it was extremely fun.
And so what were the different teams?
So there was mechanical, hardware, software, communications, art, biology, structural.
And that was it.
Yeah, that was it.
Okay. And we have one more picture. What's this one?
This is the biology team. So there was a lot of people in the biology team, because it was between kind of 3 divided groups. And I believe it was 24, like a whole class in this particular group. But it was very fun working with all of them.
Great. So we'll take some questions from the group. We'll also take some questions if you're following along online on Twitter. You can tweet Ask NASA, use the hashtag AskNASA, and we'll take questions from those in the room and online. Please raise your hand and let a microphone come to you. Introduce yourself and to whom you're directing your question. Question here.
Jim Siegel, I'm with Celebration News and Spaceflight Insider. Congratulations on this wonderful experiment and on the ability of you to convince NASA to put this in CASIS. I wasn't quite sure what happens to the worms now. They're going up. They're going to be part of this experiment. Is this package coming back down, or are they staying up there, or what?
At the end of the mission, the package will be coming back down, and we will be recovering it, and it will be sent to us about 2 weeks after the mission ends. So around the middle of August, late August, we'll be receiving the package again. We'll be examining the physical evidence, the compost, the worms in the box to see what happened, but we'll also be using the digital evidence on board the SD card to see what's happened during. The SD card is integrated, and it will be inside the box on the NESI microcontroller.
Hi, Val Phillips, 0G News. I'm kind of curious as to whether the original concept, the idea, was something that the students came up with, or whether the idea was from the teachers to a certain extent, but you're the ones who came up with the solution, which you're now putting up.
Yes. So our teacher, they actually proposed this idea. And so they actually got with CASIS, they got this chance. So then they recruited all of the 8th grade ISTEM. So then we all got to work on this experiment together.
Hi, Brenda from Space Trepreneurs, all the way from Perth, Western Australia, part of the NASA social team. Were there any big failures that you had that you could share with us? They're not failures, they're more like lessons.
Yeah, absolutely. One of our main failures involved the whole team, the mechanical team. In the beginning, we thought we were going to have a door that would separate the worms from the compost. So on the way up and in pre-flight, they would not compost. The way we fixed that is we used cold stow, where the worms are frozen essentially, so that they wouldn't compost. But to begin with, we thought we would have a servo and a little 3D printed door that would open. It turns out that didn't work very well, and the worms would get stuck in the servo and
wrap around it
and essentially butchered. So so we decided in the end that probably wouldn't be best. And when we kind of looked at our box at the end, we found that the simplest ideas usually worked the best. And this simple box, it's really just a box with 2 separate compartments. That's all it is. And that ends up working the best instead of some super complicated thing.
Like John said, we had to use cold stow. My team probably did about like 25, something like that. I don't even know how many experiments, and all of the worms ended up dying, so we had to get a new batch of worms so we could retest, and eventually it worked out just the way we wanted it to. So that was pretty nice.
And that was testing what temperature to put them at in cold stow?
4 degrees Celsius, yes.
Okay. I think we have another question in the back there.
Peter Wright with NASA Social. 2 questions. The cold stow thing, can you explain exactly what that does? And then the second question, if this experiment is a success and they do compost really well, what does that mean for the future?
So what cold stow is we want these worms to go into like hibernation just so that they won't compost, because if they do end up composting, then it's going to ruin the data that we want to see. So they have to be going into hibernation, and then once they get up to the ISS, they'll go back up to regular temperature that is on the ISS. So then they can move around, and once they go back, we are planning to have them in cold stow again, just so they can go back into hibernation, just so the flight down isn't rough on them.
And so what the main idea of this mission is to figure out if we are going to go to Mars or any planet even further, to galaxy far, far away, we need to be able to sustain our astronauts in flight. Turns out we send down nearly 100 pounds of trash for each astronaut, and that is insanely wasteful. So if we can figure out how to compost worms, how we can use worms to compost, and that way we can plant food and get it to grow faster, we can greatly reduce the amount of money and resources it takes to get to different places. And that means we also won't have to take lots of frozen, freeze-dried food on missions with us if we can just grow it.
And what's in the compost?
So what is in the compost is there is cotton balls, paper muffin cups, there's also eggshells, coffee grounds, and newspaper. So 5 different things in the compost.
Ken, you had a question?
Yeah, Ken Kramer from Universe Today and the Northeast Astronomy Forum. I wonder 2 questions. One is, will the astronauts look in flight at the data, at the worms at all, and report any observations? And the second question is, talk a little bit about more how you selected this type of worm and exact worms that are going into space. Was there a worm competition or something like that? Thank you.
You can go.
So first of all, we what was the question again? Oh yeah.
Make any observations?
Yeah. So we are not planning on having astronaut time. Our box is going to run completely by itself, and there will be no need to have anybody to touch it after it has been plugged into the rack. And the only 2 times anybody will touch it is when it's getting plugged in and when it's getting taken off. But other than that, it's completely running by itself, and everything will happen by itself.
So with choosing the red wiggler worms, they are a very sturdy worm, and so they do compost very well. There was no competition to choose these worms, but our teachers did see this worm, and it was very, very sturdy, and they compost very well. So we thought it was a great choice for worms.
And you'll get the data back after the mission is complete, not during it, right?
Yes.
Right. It'd be very difficult to get it back during the mission.
Hi, congratulations first. I was wondering, what's the total mission timeline, and do you know when particularly the experiment will be delivered back to Earth yet?
So the experiment will run for 21 days, and on August 5th, they should send it back down. So it should take about 2 weeks before we actually get to see it and see the results. So right when school actually starts for high school, but hopefully it will run like we would like it to. So yeah.
Some questions from online?
Yeah, we have a couple questions from social media. Ian asks on Twitter, how old are the worms?
They're mature.
They're mature for their age.
They're in their mid-lifespan. They're not young and they're not old. They're average and they're not all the same age, but they are. They're in that midlife.
Middle-aged worms.
Yeah.
Okay, gotcha. And then Rome asks, will anything be shared online? Will pictures be shared online? Will the public be able to see the updates? From station?
Absolutely. Bell has a Twitter, and we also have an Instagram, and all these pictures will be online. We will probably have another video going out. We've had videos during this made by our communications team. They've been posted on YouTube, and we'll definitely have another one when the data comes back on what's happened during the mission.
More questions? Val?
Hi, Val Phillips, Zero G News. What I'd like to hear is how has this inspired yourselves personally in respect of prior to becoming involved with your in respect of how you view NASA, space, and what would your plans be in the future in relation to how this has all been panning out?
So before we actually started this experiment, I was kind of into science, like I loved it, but I wasn't like my heart set on going into something with science. But after I started this and really got into it, I really loved the idea of STEM. And so hopefully I go into a STEM career when I get older. I actually want to go into biomedical engineering. Before I wanted to be a chef, which are completely different, but now I really, really want to go into that field.
So I've always been interested in space ever since I was born. Loved the idea of rockets and everything. And by doing this project, I've just gotten closer to it, and I really can't wait to go into a career that involves something that has to do with space. Not sure yet, but it's definitely going to have something to do with space.
So what's the response you get when you tell people you're flying an investigation to the space station?
Well, they're pretty much just like anyone. They're like their jaw drops, their eyes get wide. Like, it's amazing that teenagers are actually sending a project up to the ISS, and so it's amazing to see their reaction. Just because they probably never have gotten to do it at such a young age, but since we are, there's like, oh, tell us how it goes. Like, what are you guys doing? Blah, blah, blah. So it's awesome just to see the reaction that we get.
Whenever I tell somebody, they're always astounded at how we could do this when we're so young. And they're always really amazed at how dedicated we are, which that's pretty true. And they also, mostly, it's just a lot of questions and a lot of congratulations on how well we've been doing and around that.
So would you have any advice for next year's 8th graders?
Well, have simple experiments. Don't try to go overboard with like something that's too crazy, like going over their heads, but simple works. Hard probably won't. Just anything simple, like it could go up to the ISS someday.
Yeah, work hard. You'll probably achieve your goals. And if you're faced with a problem and it's not working, try to dumb it down a little, because that'll probably solve the problem and you'll still be able to do what you're trying to do. But overall, just try hard and you'll achieve your dreams.
Any last questions? Okay, great. Thank you guys very much. Did a great job. Now we're going to take a look at a video about NASA's Commercial Crew Program as we get ready for our next panelists.
Hi, I'm NASA